All right, let's go. Number 10. The Zanclean Flood, when the Atlantic Ocean drowned an entire sea. Approximately 5.33 million years ago, long before anything resembling human civilization existed, the Mediterranean Sea was gone. Not reduced, not partially dried. Gone. A geological event called the Messinian Salinity Crisis had sealed off the Strait of Gibraltar, cutting the Mediterranean basin from the Atlantic Ocean. Over hundreds of thousands of years, evaporation did what evaporation does. The water disappeared, leaving behind a vast desert basin stretching from modern-day Spain to the shores of Lebanon. Salt deposits, hundreds of meters thick, carpeted the floor. Temperatures in the deepest sections, nearly 5 kilometers below the surrounding continental shelves, would have reached extremes incompatible with complex life. The Mediterranean wasn't a sea, it was an abyss. Then the barrier broke. In 1973, geologists Kenneth Hsu and William Ryan aboard the research vessel Glomar Challenger drilled into the Mediterranean seabed and recovered something that shouldn't have existed at that depth. Layers of evaporate minerals, the kind that only form when bodies of water dry up completely, buried beneath hundreds of meters of marine sediment. The implication was staggering. The entire Mediterranean had dried out and refilled. Subsequent research by Daniel Garcia Castellanos, published in Nature in 2009, modeled how it happened. The Atlantic Ocean breached the land bridge at Gibraltar, and water began pouring through. Not as a gentle stream, as a cascade that would make every flood in recorded history look like a dripping faucet. The numbers defy comprehension. At peak flow, an estimated 100 million cubic meters of water per second surged through the breach. That's 1,000 times the discharge of the Amazon River. The Mediterranean basin, covering 2.5 million square kilometers, filled in a period estimated between several months and 2 years. Sea levels rose at rates exceeding 10 meters per day in the deepest sections. A waterfall wider than the English Channel poured from the Atlantic shelf into the empty basin with enough force to carve a channel visible on the seafloor to this day. What makes this event particularly unsettling isn't its scale, though its scale is almost incomprehensible. It's what it erased. Whatever ecosystems had colonized that dry basin over hundreds of thousands of years. Whatever evolutionary experiments were underway in that alien landscape of salt flats and extreme heat were annihilated in geological moments. An entire world drowned beneath kilometers of ocean water. No humans witnessed the Zanclean Flood. Our ancestors wouldn't walk upright for another 2 million years, but the event shaped the geography that would define human civilization. The Mediterranean Sea that would later cradle the Phoenicians, the Greeks, the Romans, the Egyptians. Every coastal culture of the ancient world exists because a rock barrier failed 5.33 million years ago, and an ocean fell into a hole. The coastlines where the first cities would rise, the shipping lanes that would carry trade across the ancient world, the fishing grounds that would feed empires. All of it was created in a flood so violent it reshaped an entire continent's geography in months. The world we inherited was built on a catastrophe so large that our species arrived millions of years too late to even comprehend what had been destroyed. Number 9. The Toba supervolcano and humanity's near extinction. Approximately 74,000 years ago, on the island of Sumatra in modern-day Indonesia, the Earth detonated. The Toba supervolcano unleashed an eruption rated 8 on the Volcanic Explosivity Index, the highest classification possible. To put this in perspective, the 1980 eruption of Mount St. Helens was a 5. Each number on the scale represents a 10-fold increase in ejected material. Toba was 1,000 times more powerful than the eruption that flattened 600 square kilometers of Pacific Northwest forest. The eruption expelled an estimated 2,800 cubic kilometers of material into the atmosphere. The resulting caldera, now filled by Lake Toba, stretches 100 kilometers long and 30 kilometers wide. It remains the largest volcanic lake on Earth, a scar so massive it's visible from orbit. Ash from the eruption has been found in sediment cores across the Indian Ocean, the South China Sea, and as far west as Lake Malawi in eastern Africa, over 7,000 kilometers from the eruption site. Layers of Toba ash up to 15 centimeters thick have been identified in Indian soil deposits, blanketing the subcontinent in a layer of volcanic debris that would have suffocated vegetation and poisoned water sources across hundreds of thousands of square kilometers. But the crater and the ash were just the beginning. The real destruction came from what the eruption put into the sky. In 1998, anthropologist Stanley Ambrose at the University of Illinois published a paper that connected Toba to something geneticists had been puzzling over for years. Human genetic diversity is remarkably low compared to other species. Chimpanzees living in a single forest in Central Africa possess more genetic variation than the entire human population of 8 billion. Something had reduced our species to an extraordinarily small breeding population at some point in our past. Ambrose proposed that Toba was the cause. The eruption injected billions of tons of sulfur dioxide and ash into the stratosphere. Sunlight dimmed. Global temperatures plummeted by an estimated 3 to 5 degrees Celsius for years. Some models suggest a volcanic winter lasting a decade or more, with regional cooling of up to 15 degrees in higher latitudes. Vegetation died. Food chains collapsed. The growing seasons that early humans depended on vanished under ash-choked skies. What makes this theory particularly disturbing is the population estimate. Genetic evidence suggests the total human breeding population may have fallen to between 3,000 and 10,000 individuals. Not 3,000 in one region, 3,000 total, on the entire planet. Every human alive today may descend from a group small enough to fill a single sports stadium. Our species didn't just face hardship, we faced extinction. The margin between humanity's survival and its total erasure was thinner than the population of a small town. Some researchers dispute the severity of the bottleneck. Archaeological evidence from sites in Africa and India shows some human populations persisted through the eruption without obvious disruption. The debate continues in journals and conferences. But what remains undisputed is the eruption itself, its magnitude, and the fact that something reduced human genetic diversity to levels that suggest a catastrophic population crash within the time frame of Toba's eruption. Coincidence is possible, but the alignment between the largest volcanic event in 2 million years and the most severe genetic bottleneck in human history demands more than dismissal. Consider the implication. If the winds had shifted differently, if the eruption had been marginally larger, if those few thousand survivors had been slightly less fortunate, every human being who has ever lived after that point, every civilization, every language, every achievement, none of it would have existed. The entire trajectory of human history balanced on whether a few thousand early humans could survive a sky that had turned to poison. Number 8. The flooding of Doggerland, the lost civilization beneath the North Sea. In 1931, a British fishing trawler called the Kalinda hauled its nets from the North Sea between England and Denmark and found something that shouldn't have been there. Tangled among the fish and seaweed was a lump of peat, and embedded within it was a barbed antler point, a tool clearly shaped by human hands. The artifact had been dredged from the seafloor, 40 meters below the surface of the open ocean. Archaeologist Clement Reid had proposed in 1913 that a landmass once connected Britain to continental Europe. But the Kalinda's discovery provided physical proof. Humans had lived on land that was now beneath the waves. That land is called Doggerland. During the last glacial maximum approximately 20,000 years ago, sea levels were 120 meters lower than today. The North Sea basin was dry land, a vast lowland plain stretching from eastern England to the Netherlands, Denmark, and beyond. This wasn't marginal territory. It was prime real estate. The landscape was a mosaic of marshes, forests, river valleys, and coastlines teeming with game. Mammoth, aurochs, red deer, and wild horse roamed its plains. Fish filled its rivers. Mesolithic hunter-gatherer communities thrived there for thousands of years. Recent seismic surveys and sediment cores have revealed the scale of what was lost. In 2007, archaeologist Vince Gaffney at the University of Birmingham used oil industry survey data to reconstruct Doggerland's topography in unprecedented detail. His team mapped river systems, lakes, coastlines, and hills beneath the North Sea floor. The landscape that emerged was larger than many modern European countries, a territory roughly the size of modern Britain itself, now completely submerged. Subsequent discoveries have only deepened the picture. Fishermen and dredging operations have recovered mammoth bones, flint tools, and even a fragment of a Neanderthal skull from the seafloor. In 2019, researchers recovered a hand axe dating to approximately 50,000 years ago from sediment pulled from the bottom of the North Sea. Doggerland wasn't just occupied during the final millennia before its flooding. It had been inhabited, on and off, for tens of thousands of years across multiple human species. Between approximately 6,500 and 6,200 BC, rising temperatures from the end of the last ice age melted the remaining ice sheets across Scandinavia and northern Europe. Sea levels rose steadily, swallowing Doggerland from its edges inward. Communities that had lived on these lowlands for millennia watched their world shrink generation by generation. Coastlines retreated. Hunting grounds flooded. River valleys became estuaries, then open sea. Entire networks of settlements, the pathways between them, the burial grounds, the sacred sites, all of it slipped beneath the water. What makes the flooding of Doggerland particularly haunting is its completeness. This wasn't a single catastrophic event. It was a slow drowning that played out over centuries, so punctuated by sudden surges as ice dams broke and meltwater pulses reached the ocean. The people of Doggerland didn't die in one dramatic moment. They retreated, adapted, relocated, and retreated again as their homeland disappeared meter by meter. Some made it to higher ground in what became Britain or Scandinavia. Others didn't. Their settlements, their tools, their dead, all of it now lies beneath 40 meters of cold North Sea water, inaccessible and largely unexcavated. The population displaced by Doggerland's submersion is impossible to calculate precisely, but at its maximum extent, the territory could have supported tens of thousands of Mesolithic inhabitants. An entire civilization's worth of human history, potentially spanning 5,000 years of continuous habitation, was erased by rising water. We know they were there because their tools wash up in fishing nets. We know almost nothing else. Their stories, their languages, their understanding of the world they inhabited are gone. Doggerland isn't lost in the sense that we forgot it. It's lost in the sense that the ocean physically consumed every trace of the people who called it home. Number 7. The 8.2 kilo-year event, when the Ice Age returned for one final assault. Approximately 8,200 years ago, the last remnants of the Great North American Ice Sheet made one final attempt to reshape the world. Not through grinding advance or slow continental freezing, but through a single catastrophic release of water so massive it disrupted the planet's climate systems for over a century. In 1960, geologist Wallace Broecker at Columbia University began studying ocean circulation patterns and discovered something that would redefine our understanding of climate stability. The Atlantic meridional overturning circulation, the vast conveyor belt of ocean currents that carries warm water northward and keeps Europe temperate, could be switched off. Not gradually over millennia, but rapidly, within decades or even years. The trigger was fresh water. Massive influxes of fresh water into the North Atlantic could dilute the salty, dense water that drives the circulation, effectively shutting down the entire system. Around 6,200 BC, the mechanism activated. Two enormous glacial lakes, Lake Agassiz and Lake Ojibwe, had been growing for thousands of years behind an ice dam in what is now central Canada. These weren't ordinary lakes. Lake Agassiz alone covered an area larger than all the modern Great Lakes combined, holding an estimated 163,000 cubic kilometers of fresh water. When the ice dam finally collapsed, this volume of water, equivalent to roughly half the water in the modern Great Lakes, drained into the Labrador Sea in a geological instant. Some estimates suggest the drainage occurred within a year. Others propose it happened in weeks. The effect was immediate and devastating. The massive freshwater pulse disrupted the Atlantic circulation system exactly as brokers' models predicted. Warm currents that kept northern Europe habitable weakened dramatically. Global temperatures dropped by an average of 1 to 3 degrees Celsius. In the North Atlantic region, the cooling was far more severe, with temperatures plummeting by up to 5 degrees in some areas. Winter conditions intensified. Growing seasons shortened by weeks. Precipitation patterns shifted across entire continents. What makes the 8.2 kiloyear event particularly terrifying is its timing. This wasn't the deep ice age, when humans survived as scattered bands of nomadic hunters accustomed to extreme cold. This was the Neolithic. Humans had begun farming. Communities in the Fertile Crescent, the Levant, and southeastern Europe had built their existence around agriculture, planting crops that required predictable seasons and stable temperatures. They had committed to a way of life that depended on climate consistency. Then the climate broke. Archaeological evidence across the Near East shows sudden abandonment of settlements, shifts from farming back to pastoral herding, and migrations away from marginal agricultural zones. In the Levant, sites that had been continuously occupied for generations showed disruption layers corresponding to the 8.2 kiloyear event. European Mesolithic communities along the Atlantic coast faced resource collapse as marine ecosystems shifted and terrestrial food sources became scarce. Ice cores from Greenland confirm the severity. The cold snap appears as a sharp, unmistakable signal in the oxygen isotope record, a sudden plunge lasting approximately 160 years before temperatures slowly recovered. The most disturbing implication isn't what the 8.2 kiloyear event destroyed, it's what it revealed. Climate stability isn't a given. It's a temporary condition that can be disrupted by a single geological event. The entire framework of human civilization, every city, every agricultural system, every economy depends on the assumption that tomorrow's climate will resemble today's. 8,000 years ago, an ice dam broke in Canada, and farming communities a continent away starved. The infrastructure of early civilization proved as fragile as the ice that held back the flood. Number 6. The Storegga Slide, the wall of water that erased a world. On October 28, 2014, a team of marine geologists, led by Peter Talling at the National Oceanography Center in Southampton, published findings quantifying one of the most powerful tsunami events in the geological record of the North Atlantic. Approximately 8,150 years ago, a section of the Norwegian continental shelf the size of Scotland detached from the seabed and slid into the deep ocean. The Storegga Slide, as it became known, displaced roughly 3,500 cubic kilometers of sediment, making it one of the largest known submarine landslides in Earth's history. The volume of material that moved was equivalent to a block of Earth 300 kilometers long, 50 kilometers wide, and several hundred meters thick, all of it collapsing into the Norwegian Sea in minutes. The resulting tsunami was unlike anything in recorded human history. Waves reached estimated heights of 25 meters along the coast of Norway. The Shetland Islands, directly in the wave's path, were struck by walls of water that geologists have traced through sediment deposits found 80 meters above modern sea level on some islands. The eastern coast of Scotland received waves estimated at 20 meters or higher. Sand deposits from the Storegga tsunami have been identified as far inland as 80 kilometers from the modern Scottish coastline, carried there by water that shouldn't have existed that far from the sea. But the most devastating impact was felt somewhere that no longer exists on any map. Doggerland, already diminished by thousands of years of rising sea levels, had been reduced to a low-lying archipelago of islands and marshland by 6,200 BC. The Mesolithic communities still clinging to these remnants of their once vast homeland were among the most vulnerable populations on Earth. Low elevation, no high ground to flee to, surrounded on all sides by the sea that had been consuming their world for generations. When the Storegga wave reached Doggerland, the effect was total. 20-meter waves sweeping across a landscape that barely rose above sea level left nothing. The archaeological evidence suggests that whatever remained of human habitation on the Doggerland remnants after approximately 6,200 BC effectively disappears from the record. The Storegga tsunami didn't just flood a coastline. It delivered the killing blow to an already dying landmass, erasing its final inhabitants in a single event. What makes the Storegga slide particularly unsettling is that it was invisible until it happened. Submarine landslides occur without surface warning. No earthquake preceded the slide that anyone on land could have felt. The ocean floor simply gave way, and minutes later, walls of water were traveling across the North Sea at speeds approaching 500 kilometers per hour. The communities of Mesolithic Scotland, Norway, and the Doggerland remnants had no concept of what was coming, or no framework for understanding why the sea had suddenly risen 20 meters and was racing inland at impossible speed. The Storegga slide wasn't the only submarine landslide in this region's geological history, and it won't be the last. The Norwegian continental margin remains geologically active. Sediment continues to accumulate on slopes that have collapsed before. The question isn't whether another submarine landslide will occur in the North Atlantic. It's when. And the populations living along those coastlines today number not in the thousands, but in the tens of millions. The Mesolithic communities destroyed by the Storegga wave had no warning and no understanding of the threat beneath their ocean. In that respect, remarkably little has changed. Number 5. The Black Sea Deluge, when the ocean swallowed a civilization whole. In 1997, some marine geologists William Ryan and Walter Pittman at Columbia University's Lamont Doherty Earth Observatory published a hypothesis that would connect ancient geology to humanity's oldest story. Using sonar mapping and sediment cores from the floor of the Black Sea, they proposed that approximately 7,600 years ago, the Mediterranean Sea breached the land barrier at the Bosporus Strait and poured into what had been a freshwater lake sitting far below modern sea level. The flood was catastrophic, rapid, and devastating to the farming communities that had settled along the lake's fertile shores. Ryan and Pittman suggested this event might be the historical basis for the flood narratives found across the ancient Near East, including the Epic of Gilgamesh and the biblical story of Noah's Ark. The evidence beneath the Black Sea is striking. Sonar surveys have revealed ancient shorelines submerged 150 meters below the current surface. Sediment cores show an abrupt transition from freshwater deposits to marine sediments, a boundary so sharp it suggests the change happened, in geological terms, almost overnight. Below that boundary, freshwater mollusks. Above it, saltwater species appear suddenly and completely. Something transformed the Black Sea from a freshwater body to a saltwater one in a period too brief for gradual transition. Ryan and Pittman's models estimated the flood's intensity at approximately 200 times the flow rate of Niagara Falls. Saltwater cascaded through the Bosporus Channel with enough force to cut a gorge still visible in bathymetric surveys. The lake's surface rose by as much as 15 centimeters per day. Shorelines retreated by over a kilometer daily in the flat northern sections of the basin. Within months, an area roughly the size of Ireland was submerged. Farming communities that had cultivated the lakeshore for generations watched the water advance toward their fields, their homes, their burial grounds, with no way to stop it and nowhere along the shore to retreat. What makes the Black Sea deluge particularly unsettling is its archaeological silence. We know people lived along those shores. The fertile lowland surrounding a freshwater lake in a semi-arid region would have been prime settlement territory during the early Neolithic. Communities in the broader region were already growing wheat, barley, and lentils, raising livestock, and building permanent structures. The lakeshore would have supported some of the most productive farmland in the ancient Near East. Yet the archaeological record from those settlements is buried under 150 meters of saltwater, effectively inaccessible. In 2000, underwater explorer Robert Ballard, famous for discovering the wreck of the Titanic, conducted expeditions to the Black Sea floor and reported finding evidence of ancient shorelines and possible man-made structures preserved in the anoxic deep water. The Black Sea's unique chemistry, its deep layers contain almost no dissolved oxygen, means that organic material on the seafloor doesn't decompose normally. Wooden structures and biological remains that would have disintegrated millennia ago in any other body of water might still exist in the darkness 150 meters down. They're perfectly preserved, but beyond practical excavation. The debate over the Black Sea deluge's speed and scale continues. Some geologists argue the flooding was more gradual, occurring over thousands of years rather than months. But what remains undisputed is the fundamental event. The Black Sea was once a smaller, lower, freshwater body. It became a larger, higher, saltwater sea. People lived on the shores that are now submerged, and the cultural memory of a catastrophic flood persists across every civilization that emerged in the surrounding region. Whatever those communities built, whatever they believed, whatever they understood about their world, the water took it all. Number 4. The collapse of Lake Megachad when the Sahara died. In 2006, a team of researchers led by geologist Mathieu Schuster at the University of Strasbourg published findings from satellite imagery and field surveys across the southern Sahara that confirmed something geologists had suspected for decades. The largest desert on Earth was once green, not marginally vegetated, not dotted with scattered oases. Green, covered in grasslands, forests, rivers, and at its center, a body of fresh water so vast it dwarfed any lake currently existing on the planet. Lake Megachad, at its maximum extent roughly 7,000 years ago, covered an estimated 400,000 square kilometers. That's larger than the modern Caspian Sea, larger than Germany. A freshwater inland sea stretching across what is now some of the most barren, uninhabitable terrain on Earth. The evidence is written into the landscape itself. Satellite imagery reveals ancient shorelines and lake sediment deposits, hundreds of kilometers from the nearest modern water source. Fossilized pollen shows grassland and woodland species that now exist only in tropical Central Africa. Rock art in the Tassili Niger Plateau of southern Algeria, first documented by French explorer Henri Lot in 1956, depicts hippos, crocodiles, giraffes, and cattle herders in landscapes that are now waterless sand seas. People didn't just pass through the Sahara. They lived there. They farmed there. They built communities around a lake the size of a small ocean. Between approximately 5000 and 3000 BC, this world collapsed. Earth's axial tilt and orbital precession gradually shifted the position of the West African monsoon, the seasonal rain belt that had sustained the green Sahara for thousands of years. As the monsoon retreated southward, rainfall declined. Lake Megachad began to shrink. Grasslands receded. Rivers dried to seasonal trickles, then vanished entirely. Climate models suggest the transition involved tipping points where small decreases in rainfall triggered disproportionate vegetation loss, which reduced moisture recycling, which decreased rainfall further, creating a feedback loop that accelerated the drying far beyond what orbital forcing alone would predict. What makes the collapse of Lake Megachad particularly disturbing is its speed relative to geological time. Core samples from Lake Yoa in northern Chad, published by Stefan Kropelin in Science in 2008, suggest the transition from green Sahara to full desert occurred over approximately 1,000 to 2,000 years. For the human communities living through it, this was a slow strangulation. Each generation inherited a world slightly drier, slightly harsher, slightly less habitable than the one before. Fishing communities along Lake Megachad's retreating shores watched the water pull back year after year, exposing mudflats that hardened into cracked earth and then into sand. The migrations triggered by this collapse may have shaped the foundations of recorded history. As the Sahara dried, populations concentrated along remaining water sources, particularly the Nile Valley. Some archaeologists, including Fakhri Hassan at University College London, have proposed that the influx of Saharan refugees into the Nile corridor provided the population density and agricultural knowledge that catalyzed the emergence of Egyptian civilization. The pyramids, the pharaohs, the hieroglyphs, the entire cultural legacy of ancient Egypt may exist because a lake larger than Germany evaporated and forced its inhabitants to crowd along the only river that still flowed. The Sahara didn't die from a single catastrophe. It died from a slow withdrawal of the conditions that sustained it, and the millions of people who called it home didn't perish in a single moment of destruction. They walked away, generation by generation, carrying whatever they could toward water that still existed. Behind them, the greatest freshwater lake the world had ever seen shrank to a fraction of its former self. Modern Lake Chad covers barely 1,500 square kilometers. The ancient shorelines of its predecessor stretch across a desert that remembers nothing of the world it used to be. Number 3. The Thera eruption, the death of the first great European civilization. In 1967, archaeologist Spiridon Marinatos began excavations at Akrotiri on the southern tip of the Greek island of Santorini. What he uncovered beneath meters of volcanic ash was extraordinary. A complete Bronze Age city, preserved like Pompeii, with multi-story buildings, sophisticated drainage systems, and frescoes of astonishing artistry. The city had been frozen in time by a volcanic eruption so powerful it reshaped the geography of the eastern Mediterranean. Approximately 3,600 years ago, the volcano that formed Santorini, known to geologists as Thera, detonated in one of the most violent eruptions of the last 10,000 years. The eruption expelled an estimated 60 cubic kilometers of material, 4 times the volume ejected by Krakatoa in 1883. The explosion collapsed the center of the island into the sea, creating the distinctive caldera that defines Santorini's crescent shape today. The Volcanic Explosivity Index rates the Thera eruption at 7, placing it among the most powerful volcanic events in recorded geological history. Ash deposits have been identified in sediment cores from the Nile Delta, the eastern Mediterranean seabed, and ice cores from Greenland, over 4,000 kilometers away. The immediate blast obliterated the island settlements. Akrotiri, miraculously, shows no human remains, suggesting the population evacuated before the final cataclysm. She likely warned by preliminary seismic activity. But evacuation from the island didn't mean survival. The eruption generated tsunamis that radiated across the eastern Mediterranean. Wave height estimates vary among researchers, but models published by tsunami geologist Kostas Sinolakis suggest waves of 9 to 15 meters struck the northern coast of Crete, just 110 kilometers to the south, within 30 minutes of the caldera collapse. Crete was the heart of the Minoan civilization, the first advanced civilization in European history. The Minoans had built palace complexes at Knossos, Phaistos, Malea, and Zakros. They possessed a written language, maintained trade networks spanning the eastern Mediterranean, and created art that wouldn't be matched in Europe for 1,000 years. Archaeological evidence from the northern Cretan coast shows destruction layers consistent with tsunami impact. Harbor installations were devastated. Coastal settlements were wrecked. The Minoan fleet, the foundation of their economic and military power, was likely crippled in a single afternoon. What makes the Thera eruption particularly terrifying is what followed the immediate destruction. The eruption injected massive quantities of sulfur dioxide into the stratosphere, creating an aerosol layer that cooled regional temperatures. Tree ring data from oaks in Ireland, bristlecone pines in California, and subfossil trees in Sweden show a pronounced growth anomaly in the mid-2nd millennium BC, consistent with volcanic cooling. For a civilization already reeling from tsunami damage, even the years of diminished harvests may have been the blow from which the Minoans never recovered. Within a generation of the eruption, Minoan civilization entered a steep decline. Mycenaean Greeks from the mainland moved into Crete. The Minoan language disappeared. Their palace complexes were repurposed or abandoned. A civilization that had thrived for over 1,000 years was consumed by a culture that had been subordinate to it just decades earlier. Some scholars, beginning with K.T. Frost in 1909, have proposed that the destruction of Thera provided the historical foundation for Plato's story of Atlantis, a powerful island civilization destroyed by catastrophe and swallowed by the sea. Whether or not Atlantis was Minoan, the parallel is precise. An advanced island culture at the height of its power, erased by forces erupting from beneath the earth it stood on. Number 2. The Younger Dryas impact, when the comet killed the Ice Age world. In 2007, nuclear physicist Richard Firestone and a team of 25 researchers published a paper in the Proceedings of the National Academy of Sciences proposing something extraordinary. Approximately 12,800 years ago, at the exact moment the Earth was emerging from the last ice age, something struck. A comet or asteroid, possibly fragmenting upon atmospheric entry, detonated over the Laurentide ice sheet covering North America. The resulting airburst triggered a cascade of destruction that sent the planet plunging back into ice age conditions for over 1,000 years. This period is called the Younger Dryas, and its onset represents one of the most abrupt climate reversals in the geological record. The evidence is embedded in a thin geological layer found at over 50 sites across 4 continents. This Younger Dryas boundary layer contains nanodiamonds, materials that form only under extreme temperatures and pressures consistent with cosmic impact. It contains microspherules, tiny glass beads created when rock melts and resolidifies in midair. It contains elevated concentrations of iridium and platinum, elements rare on Earth's surface but common in extraterrestrial objects. And at several North American sites, the boundary layer contains carbon-rich black matte sediment consistent with continent-wide wildfires. The climate data is stark. Greenland ice cores show temperatures in the North Atlantic region dropped by approximately 7 degrees Celsius within decades. The warm interglacial period that had been melting glaciers reversed almost overnight. Ice sheets stabilized or began advancing again. The warming that should have continued for thousands of years simply stopped, as if someone had flipped a switch. What makes the Younger Dryas impact hypothesis particularly disturbing is what disappeared during this period. The Clovis culture, one of the earliest well-documented human populations in North America, vanishes from the archaeological record precisely at the Younger Dryas boundary. Their distinctive fluted spear points, found across the continent in earlier sediment layers, simply stop appearing. Simultaneously, North America experienced a megafaunal extinction of staggering proportions. Mammoths, mastodons, saber-toothed cats, giant ground sloths, American camels, American horses, dire wolves, dozens of species that had survived multiple ice ages vanished within a narrow window. In total, approximately 35 genera of large mammals went extinct in the Americas during or immediately after the Younger Dryas onset. The impact hypothesis remains fiercely debated. Critics argue the nanodiamonds could have alternative origins, that the extinctions were caused by human overhunting, that the climate reversal was triggered by meltwater disruption of ocean currents rather than cosmic impact. But the coincidence is staggering. At precisely 12,800 years ago, temperatures collapsed, continent-wide fires erupted, a sophisticated human culture disappeared, and dozens of megafaunal species went extinct simultaneously. Whether the cause was a comet, meltwater, or something else entirely, the event itself is undeniable. A world was ending. If a cosmic impact triggered the Younger Dryas, it means that approximately 12,800 years ago, the trajectory of human civilization was fundamentally altered by an object from space. The Clovis people, who had colonized an entire continent, were erased. Whatever civilizations might have emerged from their expansion across the Americas, none of it materialized. The survivors started over in a world that had reverted to Ice Age conditions, surrounded by the bones of species that would never walk the Earth again. Number 1. The 4.2 kiloyear event, the drought that killed the Bronze Age. In 1993, geologist Harvey Weiss at Yale University published a paper in Science that connected a single climatic event to the simultaneous collapse of multiple civilizations across 3 continents. His excavations at Tel Leilan in northeastern Syria had revealed something troubling. A thriving urban center, part of the Akkadian Empire, the world's first true empire, had been abruptly abandoned around 2200 BC. The soil layers told the story. Beneath the abandonment horizon lay the remains of a prosperous city. Above it, centuries of wind-blown dust and sand. No destruction by war. No evidence of plague. The inhabitants simply left, and the desert moved in. What Weiss proposed was radical. The Akkadian Empire, founded by Sargon of Akkad around 2334 BC and stretching from the Persian Gulf to the Mediterranean, didn't fall to invasion or internal revolt. It was destroyed by drought. A severe aridification event beginning around 2200 BC turned the fertile agricultural heartland of northern Mesopotamia into dust. The cities that depended on rain-fed agriculture could no longer produce food. Populations fled southward toward irrigated lands along the Tigris and Euphrates, creating refugee crises that overwhelmed remaining infrastructure. The empire fragmented. Within decades, the most powerful political entity the world had ever seen had ceased to exist. But the Akkadian collapse was only one piece of the catastrophe. The 4.2 kiloyear event left its signature across the entire planet. Marine sediment cores from the Gulf of Oman, analyzed by Peter Domenical at Columbia University, show a dramatic spike in wind-blown dust at precisely this period. Speleotham records from caves in Israel, China, and Italy confirm a sharp reduction in rainfall spanning several centuries. Something disrupted global precipitation patterns on a scale that affected civilizations separated by thousands of kilometers. In Egypt, the Old Kingdom collapsed. The pharaohs who built the Great Pyramids of Giza, who had maintained centralized authority for nearly 1,000 years, lost control. The Nile's annual floods, the foundation of Egyptian agriculture, diminished catastrophically. Ankhtaphi, a provincial governor who lived during the collapse, left inscriptions describing conditions where the entire south was dying of hunger. The Old Kingdom fractured into competing provincial authorities during the First Intermediate Period, a century of chaos that Egyptians would remember as a dark age for millennia afterward. Simultaneously, 4,000 kilometers to the east, the Indus Valley civilization was collapsing. The great cities of Harappa and Mohenjo-Daro, home to an estimated 5 million people across the Indus Plain, entered terminal decline. The Ghaggar-Hakra river system weakened as monsoon patterns shifted. Urban populations dispersed. The sophisticated urban planning, standardized weights, and extensive trade networks that had defined the civilization for 700 years disintegrated. Within 2 centuries, the cities were abandoned. One of the 3 cradles of human civilization simply dissolved. In China, historical records describe the Great Flood of Gunyu, a period of catastrophic environmental instability, roughly contemporaneous with the 4.2 kiloyear event. While the Chinese experience may have involved flooding rather than drought, the underlying cause, disrupted atmospheric circulation patterns, produced devastating consequences regardless of local manifestation. What makes the 4.2 kilo-year event the most terrifying entry on this list isn't its death toll, though its death toll was staggering. It's the pattern it reveals. A single climatic shift simultaneously destroyed civilizations that had no knowledge of each other's existence. The Akkadians didn't know about the Egyptian suffering. The Egyptians had no concept of the Indus Valley's collapse. Each civilization experienced its destruction as local and incomprehensible. None of them understood that the same force was dismantling human achievement across the entire world simultaneously. The 4.2 kilo-year event lasted approximately 200 to 300 years. It wasn't a single bad season or a decade of hardship. It was centuries of diminished rainfall, failed harvests, and collapsing social order. Civilizations that had taken 1,000 years to build were erased in generations. The event was so significant that the International Commission on Stratigraphy in 2018 formally designated it as the boundary marker for the current geological age, the Megalaean, making the collapse of the Bronze Age civilizations a defining feature of the era we still inhabit. The drought ended. Civilizations eventually rebuilt. But the 4.2 kilo-year event stands as evidence that the Earth's climate doesn't negotiate with human ambition. It doesn't care how sophisticated your irrigation systems are or how permanent your monuments appear. A shift in atmospheric circulation lasting a few centuries was enough to simultaneously erase the most advanced civilizations on 3 continents. And the mechanisms that drove it could activate again for reasons we may not recognize until the damage is already irreversible. If you want to see more videos like this, click the video on screen now and make sure to subscribe.